some stuff in. So again, what I ask that people do is to start up Eclipse. I'm already in Eclipse. Create a new project named Sum of Numbers. I think I've already got one in mind called, yeah, I do. So I'm going to create one, call it Sum of Number, just so I'm going to run through the steps with you. So I've started up Eclipse. I'm going to create a new project. Tell you what, I'll call it Sum of Numbers 2. All right, click Finish as we always do. Right mouse click on it, new package. Finish up there. There's our package. Right mouse click again and create the new class, which will be Sum of Numbers. Again, Luke just asked the question, do you have to put a main in there? It's not going to matter for what we're about to do. So I'm taking for granted that all of you are right here. Okay? Correct? All right. This thing right here that says public class Sum of Numbers, keep your package line, but you can just get rid of that. Don't worry if it even gives you any errors or anything. We're going to fix this in just a minute. All right? So I want yours should say package and then followed by your package name. And that's all. If that's all you've got in there, that's good. All right. And please don't work ahead, because if you do the wrong thing, you could screw this up for everybody else. We're going to try a mass import with everybody. So I want you to go to File, Import, Existing Projects into Workspace. If I'm going too fast, you have to stop me. So File, Import, Existing projects into Workspace. Next. Then we have to tell it where this lives. So we want to browse, and you're going to have to look through Computer. We have to go out and find the P drive. We're going to have to dig our way down in there a bit. So under the P drive, the CIS folder, and under the CIS folder, the 152.143 folder, then the Spring 2015, and then the InClass, and then today's date. I don't think that's going to probably work very well, so let's see. Well, what I want to do is get inside of there because the file's in there. Do you understand what I'm saying? All right. Everybody, just for right now, everybody, just cancel out of where you are. All right. It's okay. Everything will still work just fine. All right. Go to your virtual desktop and double-click on Computer. Double-click on your P drive. Double-click on CIS. Double-click on 152.143 Java 1. Double-click on Spring 2015, and on InClass, and on today's date. Now, if you say that you did that way too fast, fine. This is the path that you want to use. Right there. If you get to that path, you're fine. All right? This thing that says Java Chapter 8 InClass examples, that's just stuff I did for the lecture I've already completed for you. All right? So if you're there, right mouse click where it says Sum of Numbers.java. Right mouse click on it, open it up in Notepad. All right? Highlight all of it except for the package line. So highlight everything that's in there. Not much. So highlight it, copy it to the clipboard, go back into Eclipse, and paste it in. And if anyone had any problems with that, raise your hand. I'll work with you, or John will work with you. So to answer Luke's question, I guess you could have put your own main in there, but now you've got the comment that goes along with it too. The entire program that I've done, the entire thing, because I didn't do as much error checking as we did in the last class, all right? But the entire program is 53 lines. Notice where we are now. We're on line 30. This isn't going to take very long to do. Did anyone have any problems? And please admit it if you had problems. What I don't like is, well, I didn't do it, but I don't want to sound stupid, so I'm not going to even say anything. Well, so if you have a problem, John will help you with it, or I will. All right. So let's get into main here. I'm going to, as always, put in some blank lines just so I've got some room here. All right, and we're in main. I'm going to first create my variables. Now, you know as well as I do, when I put this in and I move off, okay, I'm going to eventually at least probably get an error here because it's not going to understand scanner. All right, so we'll have to add that up here. Oh, I guess I already have them. Okay, so if you copied them in, you've already got those. Good. That's even better. All right. Input a list of numbers, comma, separated. Put that over 2 lines like that just so you'd be sure you could read it. All right, I didn't have to do that. I'll stop right there so everybody can catch up, and we'll talk about what we've done so far. Literally, that gets me to about line 44, so there's about 7 or 8 lines left after this. So, like I said, it's not a long program. Does everybody have up to here? Does everybody have that stuff at least? Even if you're a slow typist? Alright, so I'm going to just move that up a little bit, so we're right here. Alright, I should be able to put the rest of it in here then, because there's only about a half dozen lines. That's it. Again, we'll be done with this 10-15 minutes. I'll start on Chapter 8. We'll take a break. We'll complete Chapter 8. Next week will be lab. All right. For the Android thing that we'll do the last 3 weeks, like I said, I'm just going to probably take one of your existing programs that we've done, and we'll implement that as an Android app. All right. Now, I'll come right back to it, but I want to see if this works. So I'm going to do a run. And I did it in here, so enters a series of numbers. So it was supposed to be 7, 9, 10, 2, 18, 6, and it should say sum is 52, and it does. So it works. Again, you can blow this program out of the water by putting in non-numeric values. I didn't put that in. I should have done that and done some exception handling, etc., but I just decided to keep it real simple. If you have not heard about this already, let's see a couple things. First, if you go out, you can go out now to courses.blackhawk.edu, find out the full schedule, who's teaching what, when it's offered, etc., and my book list. So the book list for all the first semester and second semester classes are out on the P drive also. If you need help figuring out where they are, just ask. Yes. Unless somebody tells me differently. Well, if somebody comes in and offers me a really fantastic job, it hasn't happened yet. What? Are you offering me one? I'll think about it. You know, it's. There was a thing on Facebook yesterday, and maybe I mentioned to my wife. I don't know if any of you. If I said I think the second year people, they were interviewing this woman. She was like teacher of the year in Finland, and they have the best education system in the world. If you don't know that, they're rated as the top. And they asked her why. She said because we pay our teachers like doctors, and that's why they're putting out superlative people. And that's no reflection on you guys. And it's not because they're so much better or worse than I am, but they're just recognizing it for what it is. You've got companies or countries too, and I don't know. I think they still do it. I don't know if you know this or not, but like in Germany, you're typically put in a tracking type of system where they figure out by the time you're like in the middle of your high school if you're going to be going into a vocation or if you're going to be going to a university. And it sounds like just about everybody goes to one or the other. Okay, so let's take a look at it from the top then. If you're still typing a little bit, that's fine. We'll go down to the rest of it. So notice what we're doing in here. We're importing the scanner. You know why we're doing that, because we're using the keyboard type of thing, the scanner. No big thing there. If you start to use string tokenizers, and what we're doing right here is what you see in line 17 where I'm putting the mouse over, 7, 9, 10, all that stuff. That's a string. And what we're using in there for a delimiter are commas. So really there are 6 tokens in there. Does that make sense to everybody? Yes. No, it's another one that could be used. There's at least a half dozen ways this could be done. All right, but I tried to use one that was similar to what was in the book. So if people wanted to go back and look, that you'd have that. But you're right. Yeah, there's a split method. There's a lot of methods. You could have used the substring method. There's a lot of different ways that this could have been done. All right. But when we read it in, we're reading it in as a string, and then we want to parse it out. So instead of being a string with all that junk in it, we're going to basically parse it out so that we're ripping out the numbers so we can add them together. All right. Again, as I mentioned to you before, if I do a run, and it asks me to put in numbers separated by commas, and I put in 3, 4, 5, and I leave something off, or I put in hello there, the program blows up. All right? And you know now, because I showed you some simple examples, and some of the stuff that's going to be discussed next semester, there's a chapter on exception handling. I think it's chapter 11 or something like that. All right? So there's the comment. Input is literally what we're inputting in here. So in this case, it was 3, 4, 5, hello. Sum is the sum of all the inputs. Okay? So again, just use the simple scanner. This could have just as easily been done using an option, J option dialog. That could have been done that way too. All right? Enter a series of numbers, and then boom, we're entering them. All right, here's where it gets a little bit different because it's new. All right, we're creating a new variable of type StringTokenizer. So this thing that's called strtok, which is short for StringTokenizer, we're saying what we want to do is we want to split what's in input, and our delimiter to use to split that is the comma. All right, and you probably noticed, because I've already done it, if you put your mouse over that, that's one thing that you get with Eclipse, good, bad, or indifferent, but it gives you a little bit of an idea of what it is you're trying to do in here. All right, and as Mitch said, there's other ways that it could be done also. Now, one of the things that the StringTokenizer class has is it has a method called hasMoreTokens. All right, sometimes when you've got something that's called hasMoreTokens or something like that, it's referred to as either a peek, P-E-E-K, or a look-ahead method. So what this is doing is, imagine that instead of 3, 4, 5, hello, let's just say I put in 3, 4, 5. So it looks and it says, do you have more tokens? It sees the 3, yep, you still have more. Then it throws away the comma and it says, do you still have more tokens? Yep, it sees the 4. It throws away the comma and it says, do you still have more tokens? So eventually, when it looks, it won't see anything, so it'll return false. So it'll keep looking as long as there's a token in there. Yes? Are you talking about this here? But were you entering multiple strings? Here we're just entering a string. So yes, to answer your question, yes, if you put that into a loop, sure. All right. So this is saying as long as we got more stuff to add it. Like I said, this is a poor written program in that there's no exception handling in it. There really should have been, but I just tried to keep it. I just wanted us to take 15 minutes or so to see this. All right. So keep adding them. So you'll notice I had 3, 4, 5 hello, and it broke up, or it broke. And now, but if I try it with 3, gotta come down here, sorry. Yeah, now I put a 3 in there. So if I go 3, 4, 5, and hit enter, now it says 12, which is the right sum. So that's what's doing the summation. And then when we're done, we're just putting out sum is. This, just so you know, you may or may not have been doing this, but what you may have noticed is if you open up a keyboard object and you don't close it like it's done right there, the system will, at least on occasion, will warn you and tell you that it may lead to a memory leak. In other words, bad things could potentially happen. I will tell you that as many years as I've been teaching Java, sometimes I put it in if I think about it, and sometimes I don't, and it never seems like it matters. But if, you know, with most programs where this would matter, it would be a program that would be up and running all the time. If I had a program that was up and running 24/7, I would never be using the keyboard thing like this. I would always be using an option pane, all right, where I'd be using an input dialog. Because this is simple, but it's kind of klutzy, for lack of better words. All right. Any questions on what we just went over here? Because then I'm going to jump right into Chapter 8. Now, I don't like doing it this way, but A, I don't have my book, and B, I'm going to do it this way anyway. And that is, we're going to look at some of the PowerPoints that are in here. Again, I don't like PowerPoints. I was talking to an instructor from another institution. All right, we were talking, and I talked about PowerPoints, and he just laughed. He said, "I haven't shown a PowerPoint in probably 5 years." All right. There are people at this institution that not only will they be happy to show you PowerPoints, they'll be happy to read them to you. Okay. But there are a few topics that are mentioned in here that we'll just kind of go over. All right, it's 10:30. Will we be done by 11? I don't know. If possible, yes. Otherwise, we'll take a break, and then we'll finish up. And again, next week will be lab for the entire week. All right. So notice what's talked about in here are not only some of these methods, but also wrapper classes. And guess what? You already know what wrapper classes are. All right. You've done double.parse double, integer.parse int, etc. But it's going to kind of explode that and look at it in more detail than we've talked about before. All right. So I don't want to read this to you. The other thing that's discussed in here is a string builder. All right. String builder is really kind of a cool class, because if I set up a string, and I'm not going to do this, you've seen me do this kind of stuff before, where I say string name equals Jeff type of thing. If I use a string builder, string builders can expand. So in other words, I could create a string builder that had my first name. Then later I could add to that string builder my middle name. Then I could add to that string builder my last name. Then I could move the whole thing into a string. So string builders expand and collapse, all right, as needed. When you set up a regular string, it's immutable. In other words, it has a set size and stuff. So, all right, we'll go over some tokenizing and some of the wrapper classes. And then they have the same exact program that was in the C# book, where the professor has the 5 grades and then wants to add them all up and divide by 5 and get the average. All right, so that's what it ends with. So I'm writing them on the board right here. Let's hear it. What are the 8 Java primitive data types? I'm asking you. I'll start. Int, byte, char, double. That's 1, 2, 3, 4. String is not. All right, how about short and long? What's another kind? We could have not only doubles, but what else? Float. And what's our true-false called? So int, byte, short, long, char, double, float, boolean. Those are the 8 primitive Java data types. They're also known as being in their most atomic form. They can't be broken down anymore. You can only put one value into them at a time. You can change that value, but only one at a time. sometimes what you want to be able to do is take a variable that holds one of these and treat it as though it's a class variable. In other words, it's got special powers, whatever you want to say. And that's where these wrapper classes come in. So you're going to see this at the end of the chapter. Notice the wrapper classes are part of the java.lang. There's nothing special you have to import. You just start using them. All right. So you've used what? You've used integer.parseInt. You've used double.parseDouble. All right. There's also a byte.parseByte, a short.parseShort, a long.parseLong. There's not one for char. There is one for float. There's not one for Boolean. So really, there's 6 of these 8 have different wrapper classes associated with them. One thing you should notice about them is they're all numeric. All right. As it says, wrapper classes provide some of their own methods that you can use to give them a little bit more power, whatever you want to call it. All right. The character we'll get through in just go over in just a couple minutes. Now, you've seen all this stuff before. We went over this last hour. If you weren't in class last hour, again, take a quick look. I'll leave it up there for a minute. But the stuff that's in there, the names that are used here that you see is digit, is letter, etc. They're reminiscent of exactly what it is that the method does. You'll notice that every single one of these returns a Boolean. So if the condition is true, if it's a digit, it returns true. If it's not a digit, it returns false. And as I mentioned last hour, and I'm repeating it again, sometimes when somebody is putting input into something, you want to be able to look at that input on a character-by-character basis. These are functions or methods that you oftentimes use in order to do that. There's a to lowercase and there's a to uppercase. Again, I think the name is pretty descriptive of what it does. The reason that you might want to use that, I gave you an example program that we went through earlier in the semester where we when we started to go into loops, and we asked the person if they wanted to run the program again. We told them to enter a Y for yes and an N for no. But not knowing whether or not they would put in a capital Y or a lowercase y, we ran the to lower and the to upper on it. Okay. Substrings, again, a substring is a string within a string. And there is just so much stuff that's done programmatically that works with substrings that you just don't realize that it's happening. All right, one of the second-year students, she went on an interview, a job interview the other day, and it was for a company in Beloit, and they're a chemical manufacturer. All right, and some of the stuff that she'd be doing would be manipulating programmatically things for labels. So think about it. They might have a database full of stuff, and you've got to look through it and find what things meet a certain criteria. Some of the things for substrings, some of these, again, hopefully this makes sense to you. Starts with, ends with, all right? This region matches, again, there are a lot of different ways that you can handle strings. And I showed you this last hour, but it's different in here. But so please remember this, and that is, as soon as that comes up, that if I go out to java.sun.com, or I can go out to that because I never remember what that is, and go out to Java APIs, I always like to grab the latest and the greatest, which is SE8, and I go and look in here, that if I look, eventually I'll find in here there's string. So if I look in here, you may or may not have noticed it's pretty darn long. So all of the different string methods are shown here. So this chapter only gives you a subset of those string methods. There's no way it's going to go through all of them. So if you want more, all right, there's where you'd go. Bless you. And there's different ways that you can get substrings. They've got this region matches where you can go and break up a string and look in certain parts of a string, etc. again, there's an example that starts with, and that's very similar to the one I gave you before. Notice, starts with and ends with, they're both case sensitive. Well, geez. So what if I do this? All right, let's just grab this the stuff in here that's in the program. Let me grab that. Copy. All right. What if I don't know if it starts with with a big F, with a small f, etc.? What if I don't know? Well, then I can run the uppercase, the two uppercase or the two lowercase on it first, all right, and then just check for either for in uppercase or for in lowercase. Okay, so there's a lot of different ways that you can do this. You can even encrypt that, make the method call inside of here. All right, so there's a lot of different ways that this can be done. Some are better than others. Or I should say not better than others, but some read a little bit better than others do. Ends with, again, is the same. So as it says, determines if specified regions of two strings match. So maybe I've got two different documents, and I want to look in two different parts, a part of each document to see if they're the same thing. Index of, big thing is when you're counting, all right, remember you always start with 0 and you count forwards. So when you do certain things, all right, this is a good example. Score first is R, last is R, the letter R appears. So you're telling it where it begins and where it ends here. So that would be position, even though that's 0, 1, 2, I think it would say 3, and the last one would be whatever that is. The examples that they put in here are a bit convoluted because you probably really care in the Gettysburg Address when does R appear for the first time, and type of an idea, but you could do that. Again, he gives you a bunch of these tables from right out of the book. I'm not going to go over any of them. The only thing I will mention is notice here, you've seen this before in other things. Typically, if you're looking for an occurrence of something and it doesn't exist, -1 is returned. All right. You can extract a substring. This is a really important topic. Because again, if I've got a thing in there that says full name, and I want to break it up into first name, middle name, and last name, this is a way that I can do it. You can bring pretty pictures. All right. Extracting characters to arrays. Notice the string class provides methods to extract substrings in a string and store them in a character array. The reason that this is important, and I talked about this a little bit last hour, is sometimes you've got a string, but you'd like to be able to handle it like an array. So you can convert a string to an array or an array to a string. All right, if you want to. Here's some of the different methods that you can use. Okay. Returns a string object that's a concatenation of two string objects. You don't have to just even use concat, because we've been using the plus sign this semester when we want to concatenate stuff together. You can do replace, you can do trim, just the same way that we talked about in the last class. This is kind of important right here. The string class provides several overloaded value of methods. They return a string representation of whatever. So we've talked about how to take a string and convert it into something. Now we're talking about going the other way. So instead of taking a string and converting it to an integer, we're talking about how you could take an integer and convert it to a string. All right. Most of the time when you use the string value of, you can use casting also. All right. So it gives you a bunch of examples of that. It's not terribly good or bad. The string builder, again, I mentioned this before. The difference between a string and a string builder is a string builder is mutable. In other words, you can make any changes you want to make to it. I think by default, unless you specify otherwise, when you set up a string builder object, it gives you 16 bytes. That's how big it is. And if you fill up those 16 bytes, it automatically adds 16 to it. If you fill those up, it automatically adds 16 to those. But when you specify it, you can give it a number. So you could put 1,000 in there, and it would automatically give you 1,000 bytes. And as soon as you filled it up, it would automatically add another 1,000 to it. But again, the idea is what it says on the bottom here. It grows and shrinks dynamically. So it's something that's late binded. It's created at runtime. So it can be changed as the program is running, as opposed to a regular string, which is created at compile time where it's early binded. Right? So there's some of the different things that you can use with them. Again, by default, 16 characters, as I mentioned, but you can put a number in there. Notice here some of the common methods. I'm not going to read these. But what it says in here is a lot of the stuff that you can do with a string, you can also do with a string builder. All right? Much of the time when people use string builder objects, it's because they want to be able to dynamically create a string while their program is running. So they dynamically create it by using a string builder. Once it's created, then they throw it into a string. All right? That's usually how it's done. So you can append, you can add stuff to the beginning, you can add stuff to the end. I love this. The only thing is I wouldn't have called it this. I would have called it String Builder Cop. All right, I would have said we sold 12 donuts for $15.95. You know. All right. So again, you can append. When you append, by default, it's going to append to the end of your string. But if you don't want to do that, you can append anywhere you want in the string. They go through that same program that we looked at in the C# class, where you've got a phone number. All right, so if you've got parenthesis 555 parenthesis 555-1212, it removes the parentheses and the dashes, etc. Just gives you the number, and then goes in the other direction also. All right. Uses replace very similarly to the way that replace is used for a regular, quote, regular string, unquote. The example they put in here is, for lack of better words, it's kind of stupid. I mean, I like Gaddis's book. I think he's really a good author. But I think sometimes he underestimates the intelligence of the people looking at his books. All right, when you're a semi-sophisticated user, as you are, when you're in Chapter 8 of a 17-chapter book, or a 15-chapter book, or whatever it is, I think you all get that. And here's other things. Again, you can delete just as well as you can append. Okay. All right, let's jump into string tokenizers. And notice what it says. It breaks a string down into components which are known as tokens. And what's a token? It's whatever you want it to be. The same example that we saw in the earlier class. This would be an example right here that the delimiter would be a blank space, and when we do that, we'd break this up into 4 separate tokens. And your delimiter, your character, can be anything you want it to be. And you can have multiple delimiters in the same thing. All right. Now, one thing about this, if you notice in here, let's say you had 17 semicolon, 92 semicolon, etc., all this stuff. If you had 2 semicolons in a row and one of them was supposed to be a delimiter and one wasn't, the system has no way of knowing that. So it thinks every time it finds a semicolon in here, that means I've ended one token and I'm going to begin another token. Again, the process of breaking a string into tokens is tokenizing, and you need to import that util.stringtokenizer. We already saw that. Here's the different constructors that it has available. Again, nothing wrong with your book, but as I've told you before, if I've got a question about that or can't remember how it's done, then I'm going out to java.sun.com and bringing up the API. So again, this is very similar. Mitch, you asked that question. That's why I did it like this, because it's very similar to what we just looked at. So this says we're creating a new string tokenizer. That's the string, all right. And we're going to put a hyphen in there. That will be our tokenizing character. And since we put true there, it'll return the hyphens also. So it'll return an array with 8, then hyphen, then 14, then hyphen, then 2004. If you don't put true in there, it would just return 8, 14, and 2004. Here's some of the methods that it provides. I'm not going to, I'll just leave it up there for a second and you can take a look at it. We looked at the has more tokens in the program we just did. I think we use next token in there also. As it says, typically when you do this, you do it with loops. This is why I used the one that was used in the book. All right, that's the one, why I used the one, I should say, for the program example that we just went over. It's very similar to the one that's in the book. Again, if you have something like this, if you've got multiple delimiters, all you have to do is specify that there's multiple ones. All right, so this would break it up into 3 different tokens: Joe, Gaddis Books, and Com. And when you do that, as it says, you have to put both of them in a list. You wouldn't put a comma there because that would say that comma could also be a separator or a delimiter. All right, that goes back to what you'd asked about. There's also a split method. So there's a lot of different ways that this could be done. Sometimes I think maybe, I'll tell you this, you don't have to comment on it. But maybe I don't give you enough homework. Maybe I give you too much homework. Sometimes I think we should go through a problem like this one, and then I should say, now, you've got that. Now go back and change that and use the split method and do a couple other things. All right. I know a couple of you have talked to me in this class or in other classes and said, I got the homework done. What can we do to keep learning? That's a good way. Go back and rewrite some of the stuff you've already done and use some different methods. All right. Then the wrapper stuff, 10.2. Let's see, we're on slide 41, so we should finish. Again, notice there's 1, 2, 3, 4, 5, 6. As mentioned, what's missing are char and Boolean. Boolean doesn't really make sense. But this stuff is a little bit different. So in the last few slides in here, there are a couple things that are really important that you at least hear the concepts. All right? Notice what you can do. I can say integer number equals new integer 7. That looks a little weird. The key thing to realize is what's on the left-hand side of the equal sign. It's an integer, not an int. That means that number is of class integer. So there are methods and things you can do with that you can't do, all right, that you can't do with a, quote, regular integer. Okay? If you take a regular integer and you basically put a wrapper class around it, that's called autoboxing. Literally, that's the term for it. And if you take what's in one of these special kind of integers and you unwrap it so you're able to use it like a regular integer, that's called unboxing. The author talks a little bit about it in here. The reason I'm bringing that up is, I go out and read a lot of the stuff on the web, and they had a thing in there. I saw this article that if you were looking, I think it was, they're out on codeproject.com. They'll have little different things, and this one was called Java Questions and Answers. And it's stuff for if you were going to interview for a Java programmer position. One of them was, what is boxing and unboxing? And that's one you could potentially be asked. All right. You already know what the parse methods are. There's nothing new in there. Again, notice the parse methods all throw a number format exception. So if I go in here to this byte, and you may or may not know this, but byte has a range of negative 128 to positive 127. So if I try to use the type byte and I put in there 5 3s, it's too big. So it's going to throw one of these number format exceptions. All right. If I put something non-numeric in there, it'll throw a number format exception. Each of the number wrapper classes has a static toString method. We've already talked about toString. We've overwritten toString before. All right, so we've looked at these. Here's if you do want to print out stuff in binary or an octal, etc. You may or may not be aware of this. Min value and max value. That's the biggest value, for example, as it says right there, for an int that your machine will accept. And the smallest value that your machine will accept. And there's the autoboxing and unboxing. They really don't give it much play in here. That's what, slide 48. So it's a slide or two maybe. It says you can declare a wrapper class variable and then assign it a regular value. So that's declaring. That's basically saying it's a class integer, but we're giving it a regular int value. It says une. No, how about you may? It says you may think this is an error, but because the wrapper is a box, or the number is a wrapper, autoboxing occurs. That's what I mentioned to you before. And the opposite of that is called unboxing. All right. It's not that it's a hard concept, but it's a different concept. It's a different way of looking at things. Notice you rarely need to declare numeric wrapper objects because you can usually automatically just box and unbox on an as-needed basis without any problems. This was that last thing that was in there where they redid the same thing with a comma-separated variable file. I'm not going to go through that. What I will mention to you, all right, and then I'm finished, but what I will mention to you is if I go back here, close a few things here. This is the last program that you're going to be doing. All right, I did it with I didn't use the option pane, etc. All right, mainly because I just used the first one and just did a bunch of copy and paste. All right, shouldn't tell you that, but that's what I did. So today is April 15th, 2015. Who's the name? Who am I paying it to? Stefan Algendari. The amount, well, he's worth it, so it's $1 million. All right, error. No more than, oh, okay, $10,000. All right, and it writes this. See that? So it kind of creates the equivalent of a check. I've had people go nuts with this program and make it actually look like a real check. All right, I mean, went out there and researched stuff on the web, etc., and put this little thing here that I did to shame. All right. It's like next year, one of the programs that you do for applets, or at least one of the ones I've been assigning, you create a simple house. All right, you literally create it, and it's got windows, and it has a door. And the idea is, if you click on the window, it's like you pull the shade down. So the shade goes black, you know, and if you click on it again, it opens up, and the same thing with the door. Well, I've had people who've done all sorts of stuff with it. Mike Rates, who just left, he was in the last class. With his, he did a little takeoff on John Mellencamp, and he had a little pink house. You know, I've had people do all sorts of stuff, and I don't care. I'd rather have you do that and show a little bit of creativity. But I showed mine, and then I had a guy, maybe I've shown you this before, but I don't think I have. It's in here someplace. He actually went out and went to Architectural Digest and did a whole thing of a regular house. He spent 8 hours doing all the coordinates and everything, and it looks like a real house, like a log cabin. That'd be a lot more than I'd expect. All right. I said, "Can I have it?" He goes, "No, you can have the completed project and look at that, but no, you can't have it." But he offered to sell it. No, I didn't want it. So the point is, what your last problem is, the last problem that you are to do for this semester is this one that we just did, that sum of numbers. You're supposed to turn that in. And again, the last one is CheckWriter. I don't care how you implement it. I've shown you an example right here of how I did it. If you don't like the way that I did it, then do it your own way. I will try different numbers. You know, for instance, if you put in, if I ran this program again, and I'll put in, for example, 17.40. So that's, wow, 17 and 39 cents. Looks to me like I've got a mistake in my own program. All right. But I'll put in different things because I've had this already where somebody's will write out 7 there or 70. That isn't right. So that's the kind of things that you should be leery of. Does all that make sense? So lab the rest of the period today, lab next week. In the last 3 weeks, we'll go over an example of an Android application.